So we just found the derivative of this vector-valued function. We found the tangent line at t equals 1. But let's take a step back and remember from Calc 1, what's one big thing that derivatives tell us? They tell us how the quantity that we're looking at changes with respect to the input. So when we look at one of these vector-valued functions, how could one of these things change? Well, let's actually look at a few points here. So if we look at the point on the curve right here, remember r of t actually is going to give us a vector that extends from the origin and goes to that point. So r of t is going to look like that at that point. If we go to a t value slightly nearby, it'll be a point pretty close on the curve right there. R of t is going to give us the vector that extends from the origin and goes to that point. So let's look at those two vectors. What's different about them? Well, the first one's a lot longer than the second one, and they also are pointing in very different directions. If we do the same thing near that t equals 1 point that we had found before, and a nearby point. So the nearby point would look maybe something like this. When t equals 1, we've found the point on the curve to be right about there. And we can see once again that at these nearby t values, both the length of the vector is changing, and so is its direction. So when a vector changes, both its magnitude can change and its direction can change. Sometimes all we really care about is how is the direction actually changing. And so in order to do that, we want to make sure that we're looking at a notion that measures the derivative that only will take into account how is the direction going to change. And to do this, we're going to introduce this concept of a unit tangent vector. So we just saw in the picture that when this vector-valued function can change, its magnitude can change and its direction can change. So we're going to talk about what does it mean for the direction to change in a little bit, but for now I do want to show you, well, how does the magnitude change? So to see how the magnitude changes, and the magnitude we're going to denote as usual by this. So the first thing we can do is actually just compute what this is. Oops, we want r, not r prime. So we'll find this the same way that we find the magnitude of any vector. We'll take the x component, which is cosine of 5t, square it, add to it the square of the y component, sine of 5t, and then last but not least, that z component. So the nice thing after we simplify this a little bit is we should, so let's simplify it first. We have a cosine squared of 5t plus a sine squared of 5t. It's a t to the fourth. And we see our familiar Pythagorean trig identity here. We have cosine squared plus sine squared of the same angle. That's just 1. And so the magnitude of this thing is 1 plus t to the fourth. And it should be very obvious there that when t is changing, this magnitude is definitely changing.